Hi guys, Miss Berg again. We're going to be going over a new chapter. We are starting a new chapter, which is dividing fractions, chapter 8. So you will have to get your stuff from chapter 8. So get that book out. If you need to pause to remind you to get that, then go ahead and pause this. But now I'm going to go into some notes that are just quick notes. So I'm going to flip this around to get started on this. So what I need you to write down is, in order to divide fractions, there is again yet another thing to do. So this is another rule. When it comes to dividing fractions, you can't. Really, what you need to do is you will need to multiply by the reciprocal of the second fraction. Now, reciprocal, you may be saying, well, what is that? What reciprocal means is you are going to flip the fraction around. So in an example would be, for example, if it was 2/5, you are simply just going to flip it around and it is now going to be 5/2. So that's what reciprocal means. You're just flipping it around. So actually, we have a saying for this. So what you will be doing is, it is called keep, change, flip when it comes to a division of fractions. So we use keep, change, flip is the method that we will be using this time around. So let's go ahead and talk about this. It says Mia walks a 2-mile fitness trail. She stops to exercise every 1/5 of a mile. How many times does Mia stop to exercise? So it says that she is going to go 2 miles, and then she is going to stop every 1/5. So we need to figure out how many 1/5s go into 2 whole miles. So this is a division problem. So in this case, I look for, again, fraction format. So this one is a fraction format, but this one is not. So I'm going to put it over 1. So we're going to use that method, keep, change, flip. So that means here we're going to keep this one. It is going to be fine how it is. Now, when you are dividing fractions, you have to multiply by the reciprocal. So actually, that's where the change comes. The change is now no longer going to be a division sign. It is now going to be a multiplication of the reciprocal. And that reciprocal, instead of saying keep, change, reciprocal, we're going to say keep, change, flip, just to make it simple on us. So we're going to just flip this fraction around. So it's going to be 5/1. And now you just solve like you normally would on a multiplication fraction 1. So 2 times 5 is 10/1 times 1 is 1. So then your answer would be, how many ones go into 10? That would be 10. So your answer is 10. There are also other ways to go about looking at this. So this is already shown 1/5 plus another fifth. So that's 1/5, 2/5, 3/5, 4/5, and then this is 5/5, which is also 1 whole. And then this is another, each one of these is 1/5. So you could have saw 1 time 2, 3, 4, 5, 6, 7, 8, 9, 10. She would have stopped 10 times there because there are 10 1/5 and 2 wholes. There is also another way to look at it. Some people like to draw things. So this is miles. This is 1 mile, this is 2 miles, and it says how many 1/5 are in there. So what you could have done is you could have separated each of these into fifths. So this would have been 1, 2, 3, 4, 5 fifths. And then you could have separated the second mile into fifths as well. Then this would be 6, 7, 8, 9, 10. So in 2 miles, there is actually 10 1/5. 10 1/5 sections. 10 sections of 1/5. How about that? So that is what is going on. Now, they're going to ask you to check your quotients. Well, we already know that our answer came out to be 10. Now, in order to check a quotient, you would do quotient means answer to a division problem. So we would have to do the opposite. So what is the opposite of a division problem? It would be timesing. So in this case, what I would do to solve this to see if this is true, I would do the opposite of a division problem and I would times. So now I just take 10 and I work backwards. So 10 times 1/5 should equal 2 wholes. So we could see this. So 10 times 1 is 10 over 5 times 1 is 5. Now how many 5s go into 10? And it is giving you your 2. So therefore, this is true. 10/5 does equal 2 wholes. So therefore, she would stop a total of 10 times. So that is the one thing that you could look at. Here is another thing. It says, Roger has 2 yards of string. He cuts the strings into pieces that are 1/3 yard long. How many pieces of string does Roger have? Now it says to use the fraction strips. Just a reminder, I'm not a fan of fraction strips, but you could make like little things, like little rectangles. This is like you could say is 1 yard and this is 1 yard, but no, remember they're doing this in cutting it up into thirds. So we can cut this up into thirds as well. That was 1 string and this is the second string. So what we could do is we could see how many 1/3 this is total. Well, this is 1/3 and then this is another third and that's 3/3. 4, 5, and 6. So there's would be actually 6 1/3 pieces of string. So therefore, you could have done it like that and gotten your answer that is 6. You could have also done your keep, change, flip method. So it would be taking your 2 yards and you're going to divide it into 1/3 yard pieces. So here we go. We're going to see how many 1/3 go into 2 yards. So in order to do this, it needs to be in fraction formats. So then remember, keep the first one, change it to multiplication, and then you're going to flip this around. So then your answer would just be going across. 3 times 2 is 6 over 1, which is still giving you 6. So you could draw a model for this, or you could have just have done the keep, change, flip method, which is probably the one I'm going to be using the most, and get the answer as well. So your answer is 6. So in order to check this quotient, remember you have to do the opposite to check. So what is the opposite of a division problem? Would be a multiplication problem. So therefore, I'm going to do 6 times 1/3. So if I did that, 6 times 1 is 6. over 1 times 3 is 3. How many 3's go into 6? Would be your 2. So therefore, Roger would have 6 pieces of string. Okay, so now we're going to go to the next page. It says when you divide a whole number by a fraction, how does the quotient compare to the dividend? So they said quotient compared to the dividend. Quotient means answer to a division problem. And then the dividend is that number that is first, that goes into the box. So in this case, if it was like 4 divided by a half, we want to know how many halves go into 4. So we could do the keep, change, flip method. So remember, keep this. We should put it into a fraction format. So I'm going to keep it, it's 4 over 1. I'm going to change this to a times, and then I'm going to flip this to 2 over 1. So if I did that, 4 times 2 is 8 over 1, which comes out to be 8. So what happens to the quotient came out to be 8, and our dividend was a 4 originally. So what happened when we are dividing? What happens to our quotient? It is getting larger because we are finding parts of a whole. So parts of a whole, so we're finding how many halves go into 4 wholes. So that's why it's longer. Okay, so if it says describe how you would find the answer to 4 divided by 1/5 now. So I'm going to try this. Again, I'm going to do my keep, change, flip method. They should be both in fraction format. So this is just saying 4 over 1. So remember, I would keep that one 4 over 1. I'm going to change to a times, and this one I'm going to flip to 5 over 1. If you do that, that would be 20 over 1. So which would come out to be 20. So how many 1/5 go into 4 wholes? It would be 20 1/5 will go into 4 wholes. Okay, here it says Kala shares a half of a package of clay equally among herself and each of 2 friends. What fraction of a whole package of clay will each friend get? So in order to do this, it says herself and 2 friends. So that's actually not just one person, not just 2 people, that is actually 3 people. So in order to do this, it says there was only half of a package left. So that's all that was in there. So you can't flip this around and say 3 divided by a half, because what does she have? She only has a half, and then it's going to be divided amongst 3 people. Where if you're saying the other way, you're saying that there's 3 pounds of something and you're going to divide it in 1/3 of a person, which this is not what is going on. So you got to be very careful at how you determine this as well. Say what you have and then what it's going to be divided amongst. So there was only, oh, sorry, a half of a pound. Sorry, my fault. There was only a half of a pound and it's going to be divided amongst 3 people. So in order to do that, I'm going to come down here where I have some space and I am going to do my keep, change, flip method. Again, keep means just keep that one. I am going to change it to a multiplication, but then I got to flip. Well, remember 3 over 3 is the same as saying 3 over 1, but remember we got to flip this one, so it'll be 1 over 3. So then if you do this, if you go across, it would be 1/6. So therefore it's saying each person would get 1/6 of the clay. Now, if you were doing it the other way, this one would come out to be, after you flipped it around, would be 9. Now think about this for a second. Which one makes more sense? They only had a half of a package. This way, if you're going this way, you're saying that each person is going to get 9 packages. That's not even what had happened. They only had a half. So that's why you also got to go back and think, did that just make sense? So in this case, everyone should get 1/6. Now, how you go back and check is you work backwards. So it would be 1/6 times 3 should come out to be a half. So if you did this, it would be 3 over 6, which if you did reduce this down by 3s, it would be also a half. So therefore, yes, each person would get 1/6 of a package. All right, here it says divide and then check your quotient. So we're going to divide this. I'm going to do it up here. 3 divided by 1/3. Remember, use the keep, change, flip method. Do it over 1. So keep it would be 3 over 1. Change to a times, and then I'm going to flip. So then if you do that, that would be 3 times 3 is 9 over 1, which is 9. So your answer should be 9. Now it says because. Now, how would I do a multiplication problem to check this? I should work myself backward. So it would be 9 times 1/3 should equal 3. So let's see if that is true. 9 over 1 times 1/3 would be 9 over 3. How many 3's go into 9 would be 3. So this is true. All right, next, it says 3 divided by 1/6 equals blank. All right, so we are going to solve this again using the keep, change, flip. So this needs to be over 1. And remember, we keep our first one. We change to a multiplication, and then we got to flip this fraction around. So then that would come out to be 18 over 1. And how many 1's go into 18 would be 18. So it's asking how many 1/6 would be in 3 holes. This one is already cut up into 6. So 1/6, 2/6, 3/6, 4/6, 5/6, 6/6, and then you keep on going. You would get 18 of those. And then how could you check that? Again, you would have to do the opposite of a division problem, which is multiplication. So you would do 18 times 1/6. So if you did this, it would be 18 over 6. And then how many 6's go into 18? That would be 3. So therefore, this is true. All right, this one, again, you do 1/4, but then you're going to divide it by 2 people. So you can say you have like a 1/4 of a pint of ice cream, and you're going to divide it between you and your sibling. So you would do keep, change, flip. Here you would have to put it over 1. So again, keep this one, change to a times, and then flip this one around, be 1 over 2, which is 1/8. So therefore, if I took 1/4 and I divided it by 2, it should be 1/8. So therefore, how do I check this? You could always work backwards, which, remember, the opposite of a division problem is a multiplication problem. So you would do 1/8 times 2. So if you did that, that would be 2 over 8, which can be reduced down by 2 to both top and the bottom. How many 2's go into 2? That would be 1. How many 2's go into 8? That would be 4. And it would still give you your 1/4. So therefore, this is a true statement. Okay, so what I want you to do is I want you to try these ones on your own. You don't have to draw a number line or use fraction strips. You can just use the keep, change, flip model. So go ahead and try 4, 5, and 6. You may pause this and try those on your own. Okay, so you should have paused these, paused the video, and now you can see if you got the right answer. You should have kept 1 over 1, um, timesed it, and then flipped it around to 3 over 1, which would have been 3 over 1, which is still 3 wholes. Here, you would have had 3 over 1, which is kept. You would have changed it to a multiplication, then you got to multiply by the reciprocal, which is just flipping it around, 4 over 1. When you go across, that would be 12 over 1, which is 12. Here in this case, if you're going to take 1/5 and you're going to divide it by 2, you are making it into smaller pieces. So you would keep 1/5, you change it to times, and then you would flip this around to be 1 over 2, and then that would be 1/10 would be your answer. Okay, so now we're going to go on to this one. It says Luke has 1/3 of a package of dried apricots. He divides the dried apricots equally into 3 small bags. Luke gives one of the bags to a friend and keeps another 2 bags for himself. What fraction of the original package of dried apricots did Luke keep for himself? All right, so in this case, you would go ahead and look at this. It says Luke has 1/3 of a package of dried apricots. He divides them equally into 3 small bags. All right, so we know that there is 1/3 of a package left, and he's going to divide it 3 ways. So in order to do this, we would do keep, change, flip. So keep the first 1/3, change 2 times, and then flip it 1 over 3. So that would come out to be 1/9. So therefore, he has 1/9 in each package. So it says he gives 1 bag to his friend and he keeps the other 2 bags for himself. So what fraction of the original package of dried apricots did he keep for himself? Well, there's 2 ways that you can look at this. Remember, each one of them is worth 1/9. So he didn't just do 1 bag, he kept 2 bags. So you could have done 1/9 plus 1/9, or you could have also saw it as 1/9 times 2 bags. Either way, it's going to give you the same thing. So what's 1/9 plus 1/9? That would be 2/9. Or you could have just done this, which is 2/9 as well. So he has 2/9 for himself. All right, it says to do this and try this and see if they become true or false questions. I do want you to try these on your own and see if the answer comes out to be a true statement or a false statement. So go ahead and pause this and try these on your own. Okay, so you should have tried those on your own and we can see what it came out to be. So if you did the keep, change, flip on this, it would have been 4 times 3 over 1, which is 12 over 1, which is equal to 12. And this one is saying it should have been 1/12. So this is actually false. They did not flip the second one. Here, if you did a keep, change, and then flip this one around, you would have gotten 12. So yes, these are the same. So that is true. Here, you should have kept the first one, then times, and then flipped 2 over 1 as 1 over 2. And then that would have been 1/16. which is not the same as 16. So therefore that was a false statement. Here you would have done keep, change, and then flip, which would have been 1/12, which is the same as saying 1/12. So this is a true statement. And then this one, if you did keep, change, flip, keep, then you would have changed and flipped this around to 1/3, and it would have been 1/15. So is 15 and 1/15 the same? No, it is not. So then therefore that was a false statement. So that is what you should have had for those. On the next page, we are totally skipping it. So don't worry about that. We are going to go right on into your homework. Again, divide fractions and hold numbers. Don't forget, multiply by the reciprocal. Which just means flip the fraction. That's what reciprocal means. So multiply by the reciprocal of the second fraction. So, in other words, use the following method: keep, change, flip. So keep, change, flip. All right, so we are going to do number 2 together. So it says 2 divided by 1/4. So it wants to know how many 1/4 are in 2 wholes. If you want to look at this to find your answer, you can definitely check and see how many 1/4 there are, or you could use the keep, change, flip. So keep, change, flip. It was 2 divided by 1/4. Now remember, put that over 1. So this is saying 2 over 1. Change it to a times, and then flip this around to 4 over 1, which comes out to be 8 over 1, which is 8. So therefore your answer would be 8. And then you could also solve that by counting how many 1/4 there are in 2 wholes. But then how could you check this? Well, you would have to work backwards. In order to do the opposite of a division problem, you would have to times. So you would times 8, the quotient, by the divisor, which is 1/4, and it should equal 2. So if I did this, it would be 8 over 4, which how many 4s go into 8? That would be 2. So yes, this does work out. It is 2. Next, going over here, they're just saying now if you have 1/4 and you divide it 2 ways, what is your answer now? So do your keep, change, flip method again. So again, I'm going to do 1/4 divided by 2 now. Now 2 is not in fraction format, so I'm going to do 2 over 1. And now I can go ahead and do this. So I would keep 1/4, then change it to a times, and then flip this around to 1 over 2. So now just go across. 1 times 1 is 1 over 8. So therefore my answer comes out to be 1/8. And yes, this is true. If you have 1/4 of something and you are dividing it by 2 ways, you should be getting a smaller fraction because you are cutting it in half, even smaller pieces than your 1/4. So in order to check this to see if this is true, you should be using the opposite, which is multiplying. So you should do 1/8 times 2 and see if you get 1/4. So 2 times 1 is 2 over 1 times 8 is 8. And then what can go into both 2 and 8 would be 2. So how many 2's go into 2 would be 1. How many 2's go into 8 would be 4. So yes, this is again the same exact thing. So that is true. All right, so Here, I am gonna just, again, you are just going to do whatever way. If you want to use a number line and a fraction strip, you can. But I would just use keep, change, flip method on this. So I'm going to do one more with you. So keep, well, it's just one, so you could do 1/1. So remember, we're keeping 1/1. I'm going to change 2 times, and then I'm going to flip this around to 5/1. And then 5 times 1 is 5/1, which is 5. So your answer is 5. All right, here, I want you to do 5, 6, 7, 8, and 9 for homework. I am going to go over this one with you. It says Amy can run 1/10 of a mile per minute. How many minutes will it take Amy to run 3 miles? So this is what she does for every mile. Sorry, for every minute. So they want to know how long is it going to take her to do 3 miles. So in order to do this, you actually have to really watch at what you're doing. You got to see how much she wants to go. She wants to go a total of 3 miles. And we're going to see how many 1/10ths it takes her to get to 3 miles. So in this way, we would be doing keep, change, flip to see how many minutes that would take. So this is not in fraction format. So now I'm just going to go ahead and rewrite it. And now I'm going to change to a times and then flip this, which would be 10/1. So if I did this, if I went across, that would be 30/1, which is 30 minutes. You will have 11 for homework as well. Okay, and now going to the next page, you would have 1 for homework. We're going to talk about 2 real quick. When you divide a fraction less than 1 by a whole number that is greater than 1, is the quotient less than, greater than, or equal to the dividend? So it says divide a fraction less than 1. So I'm going to come up with a fraction that's less than 1. I'm going to just say like 1/10 by a whole number greater than 1. So I'm going to say divide it by 10. What is going to end up happening? Is it going to be, is the quotient, the answer, going to be greater than, less than, or equal to that dividend? So remember, this is my dividend, so I'm going to compare it to that. So if I do this, I'm going to do keep, change, flip. So I have 1/10 of something, and I'm going to split it 10 ways. That means I'm going to flip it around. That means each piece is going to be 1/100th. So what happened to the quotient compared to the dividend? Did it just get bigger, greater than, or equal to that dividend? Did the quotient get bigger, smaller, or equal to the dividend? It actually got way smaller. So therefore, smaller, less than. Because 1/100th is smaller than 1/10. Okay, and then you will have the rest of the page, 3, 4, 5, and 6 for homework. And that is it for 8-1. Okay, talk to you guys later. Bye.